I welcome everyone for this video lecture. In this video, we are going to discuss about cloud computing and other similar configurations. That is, before the invent of cloud computing, there are some of the computing techniques we are using in an IT infrastructure. So we are going to discuss about each and every computing, and we are going to compare with the cloud computing and why we go for the cloud computing. The cloud computing is often compared with other computing architectures like peer-to-peer, client-server, grid computing, distributed computing, and clustered computing. So these are the similar configurations which we will be using in IT infrastructure before we go for the cloud computing resources. Peer-to-peer architecture. So what does it mean by a peer-to-peer architecture? It is a collection of hosts. So every computer is connected in a network and they are used for sharing the resources, task processing and communication. Each host on the network acts as a server and has an equal right in terms of providing and using resources where users are authenticated by each individual workstation. In peer-to-peer architecture, there is no controller or server who can control the access and communication between the hosts. That makes the performance bottleneck. It means there are 5 number of computers are connected in a peer-to-peer network. The 5 will act as a server. So there will be a bottleneck. The communication happens in peer-to-peer is completely decentralized. This is in peer-to-peer. You can see all the hosts are computed with every computer. That A can access B, C, D and E. So each and everything, whereas the B can access C, D, E, A. So every system will act as a server. The limitation of peer-to-peer architecture is the lack of scalability, poor performance, low throughput, limited flexibility. These limitations are overcome by cloud computing by making architecture fully centralized. When we talk about peer-to-peer, it is decentralized. When we go for cloud computing, it is a centralized. It can provide automated scaling, high performance, flexibility, and mobility. Next one is a client-server architecture. In client-server architecture, there is at least one specialized service which controls the communication between multiple clients. Typically, there is a server called controller who provide access to the network services like shared files, shared printers, hardware storage, and application to the client who are requesting. So this is a server which is connected with a 4 client. So each and every client will be working with the instruction from the server is processed. The client will act as the server instruction. That is called as a client to server architecture. The server is responsible for handling the resources sharing, task processing and communication between the clients. So the client has to rely on the server for various access and services. It is faster than peer-to-peer architecture as the server is responsible for granting and denying permission for access. The client-server architecture has centralized processing which makes a faster communication with good performance. The cloud computing also follows the client-server architecture but massive in size that gives a seamless delivery of services with flexibility, scalability, mobility at lower cost. That means in cloud, client and server, when we compare to the cloud computing, it is also following the same thing, but the client will be n number of clients. There's a large number of clients will be connected with the n number of servers. Whereas a grid computing architecture is a geographically distributed computing resources which work together to perform a common task. Typically, grid has a pool of loosely coupled computers who work together to solve a complex computational problem. It has heterogeneous resources which are controlled by a common node called control node like client-server architecture. Conceptually, grid computing works similar to cloud computing for providing services through a shared pool of resources. The grid computing follows a distributed architecture while cloud computing follows centralized and distributed architecture. In grid computing, the compute resources are distributed across cities, countries and continents. Therefore, they are managed completely in a distributed manner, while in cloud computing, although the resources are distributed, but they are managed centrally. So this is the main difference between the grid and cloud. Grid is a distributed manner over the cities, countries and continents, where the cloud is also a distributed manner, but it is accessed and managed centrally. When we come for distributed computing, it is a computing concept that refers to the multiple computer systems works on a single problem. In distributed computing, a single problem is divided into many parts. Each part is executed by different computers. As long as computers are networked, they can communicate with each other to solve the problem. If it is done properly, the computers performs like a single entity. The ultimate goal of distributed computing is to maximize the performance by connecting the users and IT resources in a cost-effective, transparent, and reliable manner. This type of computing is highly scalable. Next, we go for the cluster computing. Cluster, we know it is nothing but a grouping of some set of resources. A cluster is also invented to solve the complex computational problems in a group of computers connected to a network. Generally, cluster is a collection of interconnected, loosely coupled homogeneous computers that work together closely so that in some respects they can be regarded as a single computer. Each cluster is composed of multiple standalone machines connected by a network. The modern clusters are typically designed to handle more difficult problems that require needs to show intermediate results with each other, very often that requires high bandwidth and low latency interconnection networks. This is called as a cluster and architecture. That is, we have a cluster 1, cluster 2. Cluster 2, we can see cluster 1 we have a master slave where the input is given and it is the result. And there we have a servers 1, 2, 3 and desktops and workstations and IO devices, disk array. Everything is connected with the internet connection called as LAN, SAN and NAS. Whereas the same set will have a cluster 2 and both the clusters are connected by a internet. So this is a cluster. So when we come across the several configurations regarding to the cluster computing, it has the same set of components, but it is joining the same set of components through internet is called a cluster architecture. So why we go for a cloud computing is, it is the resources, mainly we talk about the resources, can be managed in a centrally way, that for that only we are going for the cloud computing. So we have seen the peer-to-peer architecture, client server, and grid computing, distributed cluster computing, and nowadays we are going for the cloud computing as a for resource sharing and process was for the speedy process. Thank you, students.